But I want to let you know that that MediaCon is not really a brand new company. It's got 50 or you got since the mid '90s history of compression and everything else, and we're not going anywhere. So don't listen to other people that are out there. So at this point, I want to introduce our guest speaker. Chris Whitmire is the director. Broadcast production and new media technology. Been with NASCAR for 12 years. So I've known him, watched him grow up in NASCAR. And glad to see it maturing out okay. Not that I've had any effect on that. But Chris has been really moving NASCAR in a different direction as far as content, doing live production at the tracks and everything else. And what he's going to talk about tonight is still moving in that direction with all the different players and all. So with that, I give you Chris Whitmire.
Thank you, Dan. It's true, over the last 12 years, I really have looked just the same. In fact, I don't think I've aged much. Thank you for the food, Dan. Thank you, Turner, for inviting me down. I'm Chris Whitmire. I'm the Director of Broadcast Production and New Media Technologies. Dan mentioned I've been there for about 12 years. Prior to that, I was with NFL Films. Today, I'm going to give you a presentation that we did at SMPTE. It's the first time we've shown this, was just a few weeks ago. And how many people were actually at SMPTE in LA? Excellent, I see a few of you. And with that, I'm going to start off with who we are. The Director of Broadcast Production and New Media Technology for NASCAR, AMA Pro, and IMSA Sports Car Racing. 3 different brands, all coming up in one family of NASCAR. I also have to ask the next question. I see some Turner folks here who probably know NASCAR, but does everyone know NASCAR? See some head shake. All right, good. The next question is, who's the number 43?
Richard Petty.
All right, excellent. Yes, yes. I had to put this in there from last time. It turned out that a lot of people in LA didn't know a lot of NASCAR stuff, so I had to give them some facts really quick. That's Richard Petty. We would also accepted Bubba Wallace as an answer, for those that you were looking for. There you go. So at NASCAR, we have about 500,000 hours of content in our library. That's approximately 300 hours of ingested content every new week, and it's about 1.2 petabytes a year of content we're bringing in. Now, that's strictly talking about video. We were talking about audio. It's more like 760,000 hours. We were talking still images in there. We're looking at probably close to 750,000. We just continue to grow. However, we only use 1% of that footage in the first week. So we've been tracking this for years, and this number has remained the same. So the question we ask is, should we move to the library to the cloud? Was the first thing we came up with, right? Management says, cloud, go do. But is it practical, right? So that was our second question we were going to ask here. Well, where do we use our content? As you can see, we use it in live production, right? We're going to make TV shows right there at the track, send it out over NBC or Fox. We're going to use it in post-production. We're going to take these shows, come up with new content, and produce that all and have it available on Tuesday, Wednesday, et cetera, to get you psyched for the next week of racing. We're going to use it in live streaming. We deliver a lot of different camera angles to our fans, both at the track and abroad, mobile. And we're starting to use more of it in officiating, right? So we've got special cameras just out there for officiating the race using things like Hawkeye. We also have to log the footage, and of course, there's plenty of other things we can do with it. So as you can see, we're looking at just a few key areas today. We're going to focus on 3 of them, although the other ones are always in our consideration. Here's our current high-level workflow. It's pretty complicated. I'll walk you through it. And this will be available online, I suspect. What we're going to do is we're going to take all those camera angles. We're going to talk about live. We're going to bring that back over satellite, ingest it all into our system, make all the different mezzanine files, the proxy files, streaming files, all these different things. They're going to go into our online storage. It's going to tier over into nearline storage, eventually make its way to LTO6 tape. And then we'll have a second copy that's also made and delivered off-site. We do the same thing for all of our ENG footage as well. It's a lot of stuff, a lot of hardware in our facility. That hardware is only really in use about 30% of the time. Highly inefficient. So what can we do with this? Oh, sorry, this is streaming we're going to talk about. So streaming comes in very similarly across satellite. Over ASI, we're going to bring it into our encoders, decode that, and generate HLS streaming files and deliver it to our fans. So Can we be more efficient? Our proposal is yes. Here's what we're going to do. What we're going to talk about today, and we've demonstrated this to work in January of this past year, 2018. What we're going to do is we're going to take a stream from the track, the highest bit rate we can support. We're going to deliver it over the internet to a cloud platform, whether it's Azure or AWS or IBM or whoever it may be, whoever you choose. Very open in this concept. We're going to use the decoder. We're going to unwrap that file and rewrap it to the specific formats we need. With an RTP stream, basically real time, we can deliver it to object detection such as TensorFlow or any sort of SSD or CBS solution. We can go to HLS, delivering all the different bit rates and send it directly to Akamai or whoever your CDN may be. Of course, we want that mezzanine file. This is going to be a full 720p Apple ProRes 100 file. And I'm sure the next question will be, what about HDR and all those other things? We can certainly chat about that later. But for today, it's 720p ProRes. And deliver that directly to nearline storage because, again, we only use 1% of our footage. And then, of course, we can take another RTP stream and deliver it to our officiating software. And the value of this solution is that we could take any other file format and generate it from the cloud. So, what are our constraints? There's actually 3 circles. We put a 4th one up there, but no one ever has 4 circles, and I had no idea how to make that whole thing work. So you get 3, the most important ones. The 4th being money, which I don't really pay attention to. Anyway, bandwidth, latency, and quality. So when you think about these things, your archive, you want the highest quality product. Okay, well, that probably is going to take a lot of bandwidth to get out, as we all know. If we want to do officiating, it's going to take a lot of, we're going to have to open up that pipe and have less latency for the streaming format. And so as we start to think about these things, officiating, archive solution, live streaming, each one of those has a constraint we must be prepared to support. And of course, all of them cost some sort of money, so add that in there in your 4th circle. So how does it work? What we've done is we have 2 different options. The first one is we're going to take that source at the track, we're going to encode it, and we're going to send it over IP in a layer 2 circuit to our cloud provider over RTP. Now that RTP is pretty low latency, and it's going to go to our cloud encoder. Now, if you lose packets on that one, it's less likely to recover. So while it's quick, it does have some flaws with it. So you need to make sure you have a reliable connection. So we're going to encode that at HEVC, deliver RTP. Now, the next way, option 2, take that same video source, encode it, and actually write it very quickly to the storage using TIFO. So again, using HEVC, write the file to the storage, and then quickly restream it back out over something that has more quality and more respect for the internet, if you will, make sure all the packets are delivered, such as Aspera. Bring it back and capture it by that encoder in the cloud, write it back to storage, and then stream it back out. Okay? So I had an engineer explain this one to me. This got a little deep. Signal-to-noise ratio. How many people know what that means? Good. You were in the same boat I was in when I said, does it look as good? Signal-to-noise ratio. Basically what it means, did my signal, when it started, look the same as what at the end? So we took that exact same ProRes file, we encoded in HEVC at 33 megabits. This was the sweet spot for us. Generated a 720p 5994 file, streamed it out, re-encoded it back to ProRes, and we found that the original file and the resulting file had a signal-noise ratio of 0.5 dB. That's impressive. I couldn't tell, and that's what the actual
The difference between
the difference between the two was 0.5 dB. Sorry, there's clearly one engineer way in the back who caught that one. Yes, the difference between the two is 0.5 dB. So what we've proven is that we can actually take a 33 megabit stream and make it look like 100 megabits when it gets to ProRes, and you would never know the difference. And we could do all that over the internet. So what does this new workflow look like? In this particular case, we took the single encoder. We used a couple of them. I'll go into that in just a second. We encoded it. We sent it up to, in this particular case, a virtual machine running software to decode it and to re-encode those files. In this particular case, we've demonstrated 3 different products, Ericsson, Telestream, and Invivio on all different ends. Because of the scalability of the cloud, as you had heard, I said 30% efficiency on those systems at the office. We have 13 Lightspeed encoders which means they're only in use for 30% of the time, but we need all 13 at that given moment. We, of course, have all these streaming encoders as well, but they're only used for a period of 3 or 4 days. So we're investing a lot of money in upfront hardware when really all we need to do is scale up at the times of need. In this particular case, the cloud allowed us to scale. We then generated all 5 of these formats out, 4, and we proved this thing to successfully work. In January of this past year, we've been demonstrating for probably 4 or 5 months. Yes?
How many paths are there actually on the left side?
Sure. So each channel of video is a single path. So in this particular case, we will start using about 24 channels at max. We've demonstrated 3 or 4 at one time. We didn't have enough encoders on the ground to demonstrate this in heavier usage, but based on what we see right now, it's very successful. Open architecture. We are big believers in the open architecture. We never want to be held captive by a vendor. We have very few scenarios where we can't say, thank you, we're leaving, right? In this particular case, we tested it out with 3 different cloud vendors, 3 different encoders, and 3 different cloud encoders as well. And as you can see in this lovely chart right here, it doesn't matter if you have Ericsson on the ground or a Telestream on the ground or an Elemental, they will all work with each other. It's completely separate systems. And in fact, one of the reasons that we really like the Ericsson encoder, not to promote any one product at a SMPTE thing, but we already had those. And by simply adding in the HEVC card, we were able to actually expand our workflow without changing out chassis, right? Whereas the other ones are strictly streaming only. So kind of an interesting way to look at it. And so, again, demonstrate all 3 of those. So how well did it work? So I'm going to strain my eyes to see. The ground encoder was a half a second delay from the time we encoded the video to the time we were able to actually start writing with it in the cloud. That was from California. That was from Charlotte. Really from anywhere that we've demonstrated. The ground encoder to the proxy took about a second. So instead of gathering all those files back in our office, transcoding them, and giving them somebody for an offline workflow, we were able to give them to them within seconds. The mezzanine file was 1 to 2 seconds. Again, if we really wanted to, we could have this available for an online edit within minutes. The encoding to HLS was 4 to 9 seconds. That was from the ground all the way to the fan experience. Using low latency streaming, you can get down to 4 seconds, about 4.5 more accurately, is the best we've seen. And then of course with ML, we're under a second. We can almost officiate a race with machine learning technology from this encoder remotely. No longer do we have to have all these trucks at the track, we can start bringing this content back to the office. So, what are the advantages of the cloud contribution? More efficient use of bandwidth at the track. In our particular case, we're sending back stuff over satellite, we're sending it back over IP solutions, we're sending back 4 and 5 different copies of things, we've got a spare out there. We just seem to pump as much stuff as we can across the line. What if we simplified all of that to the 24 channels we needed and packetized in the ENG footage? We can trigger multiple workflows from one source. We're all being asked to deliver more content and much quicker. In this particular case, we can take that single stream and we can do 5 things with it. You could do 6, 7, 8. You can do whatever you really want with this product now. It also means that you can reduce staff. And while this is certainly not something that I want to promote and say we don't love our employees, we do. We're simply saying, can they be more efficient in their existing job? Because now instead of waiting for files to come back to ingest, what if they were ingesting it at the track at that time? No longer are you waiting for tape returns at 2 in the morning. You're now ingesting it live. It also reduces your ability for mistakes. If you've recorded it and captured it once, you're good to go. Now, it also means you can have more mistakes if you forgot to capture it. Well, we have a problem. We haven't solved that one yet. But it allows for less mistakes. It also allows us to reduce that CapEx. As we continue to go on and we're asked to reduce budgets and find new ways to deliver content, taking things to the cloud and reducing 60% of our overhead for capital expenditures is pretty crazy. And so by doing this, we can now take all those encoders that we're currently buying and we can put them at the track, the ones that we need, and we can offload the other ones to the cloud and simply expand by using licensing pool technology. Ericsson offers it, Telestream offers it, etc., where we simply scale up as we need and pay for the licenses as we go. And of course, it allows us to be in the cloud to support any other workflows we might want to do. Any questions? Yes, Bob, questions?
So where does EVS fall into this? Or all the clips they store in EVS?
Yeah, so the question, where does EVS fall into this? I typically focus most of my life on streaming and post-production assets, and this works perfect for that. We don't believe we have a solution for an EVS as of yet. Could we take this back and stream it back into the EVS live? I suspect so. We haven't solved for that. We're really looking at how to archive and how to get it out immediately.
So in other words, the encoders, when you're going to ATC sort of satellite, or you hand that off to like a PSM that uplink it, the same, is that the same encoder then?
Yeah, with the Ericsson encoder, we're able to deliver one path to satellite and one path to cloud contribution. Elemental and Telestream cannot support that workflow. There are some changes in configurations in your ABC encoders. I suspect the name will change at some point based on media kind, but the point being is that, yeah, we were able to shove 2 channels per encoder doing 33 megabits right now. Yes?
So typical event, you've got a race going on, how many streams, because you have multiple cameras, you're not mixing them to one and then sending it out, you're recording multiple cameras, and
Correct.
so how many?
We're not muxing them. Right now, you'll see up to 38 cameras. At the end of this project, we estimate we'll be streaming 24 channels back to our office or back to the cloud. Some of those corner cams may not be as valuable to us. They're great for live production, but if you think about it, they're only used 1/4 of the time.
So what bandwidth are you looking at coming out of the site if you have 24 cameras?
Yes. I haven't fully done the math off the top of my head. Yeah, it's 33 megabits. Start doing the math on that. I will say when I first started at NASCAR, we had 9 meg connections. That was, yeah, really bad. That's why we really relied on satellite. We're right now at gig infrastructure, and we're moving towards 10 gig by, I believe, the end of the season.
That's about 800-900, somewhere around there,
Yeah.
megabits.
Yep. So we're continuing to expand on that. We're working on better ways to support this, but as of right now, the proof of concept shows we can do it. And if we can now invest more into the IP infrastructure, we can reduce on the actual capital costs. Yes?
You talked about putting stuff into the cloud.
Mm-hmm.
As everybody, most people in this room know, most of the business models, they get really cheap to put it into the cloud, and not so cheap to take it out of the cloud.
Yes.
And if a lot of stuff is going in and not being used, I can see that being a good business model. But if you start using a lot of it, you expect that to be cost effective.
Yes, we do. We've been doing a model now for about 18 months. I look forward to telling you, hopefully another SMPTE meeting, the cloud provider we've selected. As of right now, I can't. But I can tell you when you start to talk about putting 15 petabytes into the cloud and you're using only 1% of the weekly footage, we restore about 30 terabytes a month of usage. And so when you start to do all that math, it's actually break even right now. And that's across most cloud providers. So I'm going to say that the cloud is actually pretty good. And I suspect as the years go on, it's going to get cheaper. It's a race to the bottom for storage.
So that still holds for, as you say, would you say 1 petabyte a year?
1.2 petabytes, yeah.
1.2 petabytes. As it builds and builds, keeping it in the cloud is still cost effective for you?
Yeah. Glenn's back there. So Glenn from SpectraLogic, he's our robot provider. This is the first time he's going to hear this. Yes, when one does a tape migration, we started off on LTO4. We migrated 12 petabytes of content. That migration took 1.5 years to migrate, I want to say 6,000 tapes to LTO6. And we only ever ended up migrating half of the tapes because we had one person, 20% of his time was dedicated just to migrating tapes. When you're paying for an engineer with great value, do you want to be having them manage tape migrations? Now, we all know the concept of the tape migration was that you should be able to put a 4 and a 6, right? An LTO4 tape into an LTO6 drive. The real answer is it doesn't quite work that way. Now, we don't hold SpectraLogic for that. We hold the IBM, or we hold the consortium to that. It doesn't work as planned. And so what we've looked at is that by the time we start the migration from LTO6 to LTO8, we will have 15 petabytes. And at that point, it will take us 4 years. At the completion of that 4 years, we will have already started migrating from LTO8 to LTO10, and we'll be employing someone full-time to do tape migrations. If you'd like, I have a spreadsheet that shows this. At this point, we don't believe migrations to be the successful answer when you're talking about the size of our tape robot.
But your cloud provider is taking care of, once you get it into the cloud, they're taking care of everything for you.
That is correct, yeah. At the end of the day, we don't care if it's on disk or tape. We know that most of it, depending on your cloud provider, is going to be on disk. and the restore times are within seconds.
Even with, your service level agreement in terms of, I want something from 8 years ago obscure, your delay in getting it is not,
Not excessive. Right now, we have 24 drives, and we will wait up to 24 hours for a full restore. It's pretty crazy, yes. It changes the model. Yes, red shirt.
Following up a little bit on what Bob was touching on there, if somebody runs over your cloud with a backhoe, how is your downlink teleport, back into your distribution path? Is that like a glitch? We'll be back in 1 minute? What is that like?
flying back to.
Don't ever speak of that. The statement, what happens if we lose connectivity to the cloud? We will not be broadcasting live television over this. This is officiating. This is archiving, live streaming, etc. We believe at some point in time, IP will be the best solution for us, keeping in mind, if you're with the NFL, you're in a local city. If you are perhaps NASCAR, the nearest track is about 45 minutes south of here. That's a lot of fiber to run. It's a lot of different connectivity and paths. We have a special challenge. We are working on diverse paths. Our facility is diverse to our cloud provider. So we're going north and south. So our building is perfectly fine. We also suspect that as we move forward with this, our tracks will be diverse as well. Yes, Dan?
So, you know, you talked about you're running 24 feeds now, but you're in the process of trying to get live feeds out of all 40 cars. So those feeds would go from 24 to 40 or even more.
We'd be at 64, yeah.
Yeah. So.
Yeah. So Dan mentioned there's a project out there, and he's been helping us on this one as well. We're looking to put in in-car cameras in every single NASCAR vehicle to give you a different experience, right? We currently do 8 to 12, depending on the race. And it's really cool. You can sit next to the driver and watch what they're doing. But what if we did full 360 and give you an immersive experience? And what if we were to do that for every single car? If you think about the way live TV is produced, we're typically only going to follow the top 10, top 12 cars. That's where the action's at. And perhaps somebody who's typically famous if they fall back in the pack. But, you know, if your favorite driver runs 38th all the time, you should still get to watch your favorite driver. And so we are working towards that. There's a timeline on that. I suspect you'll be seeing it on another presentation, but as of today, no hard timelines.
Are you editing in the cloud, or do you bring the content down for post-production?
So right now, all this has been testing until we can actually go live and basically say, here's our provider, and start firing everything to the cloud. We're looking at about an 18-month migration process right now to move 15 petabytes of data, run machine learning on top of that. If you guys want, I can talk about AI later and how we're utilizing that. But all the post-production work has to be done on the ground. We found that while there are some solutions of virtualizing your desktop and things like that, the gig throughput required in just the general process, including the fact that we use ProRes, which cannot be used on a PC with Premiere, is a little bit of a glitch. We'll work through that one, hopefully. But at the end of the day, our goal here is to actually send all the proxies back to the office so they can edit, and then as you need something, you can restore from the cloud. We've proven this to work beginning to end. You first, start.
I assume you are also doing a lot of metadata. So when you have the cameras in the car, you're also getting speed, RPM, all that sort of stuff, I assume.
Mm-hmm.
And so you're tying or sending that and tying it along with the video feed. I don't know if you're doing MXF or if you're making it a separate feed. How is that done? So currently that's all handled by Sport Vision, and we bring that data back into the office. The merger of that ends up causing something we would call metadata clutter. So right now we logged, I think it's, and I have a presentation for this, so I'm going to memorize really quickly. We have 500,000 hours of content. Of that, we have 9 million metadata points that have all been manually logged by hand, over between 10 and 13 people over the last 12 years. Yes, that is excessive. So we're trying to work on doing that better. The scary part is that's only about 12% of our entire library has been logged. I believe it's 78,000 hours of content. So your question of how do I get all that live data ingested? We are working towards that. We're just trying to find a way to make sure it's valid. And what I'm saying is if you were to say every time Jimmy Johnson, he's a driver, passes another driver, I had to clarify for the non-NASCAR fans, every time he passes, that could happen hundreds of times. In fact, one of the fun facts I have about IMSA, our 24-hour sports car series, Daytona Rolex 24, we have 17 million metadata points. That's a lot. How do you ever figure out which one is valid? So we're working on ways to give it weight.
and we'll hopefully tell you about that soon.
But that metadata is not married in, let's
No.
say, fed into the video with MXF or something like that?
No, it is currently not. We separate all metadata. If it comes in with a stream, we take it out and put it into our archive. The reason being is that if something ever happens to the file, if we want to do anything else and change things, we refuse to wrap metadata outside of generic EXIF and things like that in the actual file itself. For us, there is no value to that. Yes, sorry.
And all your content is with one cloud provider?
Yes, that is the plan. Question is, are we with one cloud provider? Yeah. If you think about it, you look at it as a long-term commitment. We've actually looked at our exit strategies as well. I really look forward to telling you about where we've gone with this. And perhaps you guys will invite me back and we'll go into a deep dive and show you all the Excel grids and everything. We have chosen one cloud provider. We don't believe it's cost effective for us and our business to separate the two different clouds. Other companies may consider that. If you're bigger, perhaps Turner would do that or Discovery. For our business, we don't see that as being something we want to do. Yes?
My only question was that, it's not a technical question, but it's what the business relationship sours.
There's a lot of contracts in place. Yeah. What if the business relationship sours? I think you can answer that. You could say that for any question, right? What if a business relationship sours with an employee, right? At some point, you have to figure out how to terminate that. We look at this as being a 5-year deal. We understand the exit strategy and the exact cost of the penny it will take us to move out of this particular situation. So we are really informed about how to do this. It is a commitment, and like I said, I really look forward to telling you about this one in a couple of weeks.
Question from the streaming, how do you see this affecting the traditional live event using mobile drones?
Is that from somebody from NEP? Question, how do we see it affecting the live event? It costs a lot of money to put on a live event. It's inefficient, right? It worked for years, and it still does work, right? There's a need to have live editorial at the track. There's a need for a lot of those resources. But can we find a better and more efficient way to do it? And we believe so. We believe there will be a reduction in trucks in this particular environment. How we're handling it, we travel 27 trucks right now around the country. 38 weekends a year to make sure these events go on. And if we can reduce 1 or 2 trucks and allow someone to see their family on the weekend after they get done work, instead of hanging out in Talladega, they might actually enjoy that. And so our objective is to reduce the cost of the track, be more efficient. Maybe this all trickles through and allows us more business opportunities, right? Can we do other unique things having saved that money?
Do all your tracks have fiber?
Yes. As of a couple of months ago, yes. In the back, yes.
When you were talking about the live streaming of the 360 cameras and everything, I think you were saying that 33 megabits for the 720. So what about those 360 cameras? Because usually they're larger resolutions and everything as well.
That is correct, yes. So 4K solution for live streaming, we do 10.8 megabits, and it is more than sufficient. We've run into other hiccups, like how do you get 4K out of a car over RF, right? What other solutions are there? Different compression ratios, et cetera. And again, that is for a future conversation we'll be talking about. I see Dan smiling back there. Yes, right now our highest stream rate is 10.8 megabits on live streaming. And if those that are following along, that is the Apple standard for 1080p, as well as I believe 4K, and it looks pretty good. In the red in the way back, yeah.
Yeah, so I was wondering, your primary product is a live product, right?
Yes. Well, mine or NASCAR in general? The NASCAR race itself, I believe, yeah.
NASCAR in general is generally oriented around the live event, right? I mean,
that is correct.
Right?
Yep.
So I'm just curious from a business standpoint, in a way, it seems like the application is a little bit like archiving news footage. I mean, I can imagine officiating with the live replay, right? Did the guy bump him or not, when he went off the track or whatever. But are there like long tail opportunities or the opportunities to put together a package on Richard Petty when he retires or whatever? Is that mostly the sort of stuff that you're looking at using this long-term storage for?
Yeah, so the question is what are we doing, right? We are a live business. NASCAR is pretty relevant on Friday, Saturday, Sunday with the different series. We do archive nearly every piece of footage because we don't know what's going to happen. If we knew it was going to happen in the race, we would be WWE. Love them, just saying. We don't know which camera angle is going to, now I'm going to hear it. I'm going to hear from those guys. look, we don't know which angle is going to be great, and so we're going to record it all. And since we recorded it, what if we want to do something in the future? Perhaps replay that entire race, perhaps re-edit that race, perhaps make that a footage available. The cost per gigabyte is sub-penny for us at this point in time. So at the end of the day, the overall cost isn't that horrible to keep it all. We do toss some of that, right? Some of the corner cameras, we make special rolls, melts, if you will, and keep that, right? If there's nothing happening, why keep it? But we found for the most part doing that and doing melts of every single camera is highly inefficient for us. And it's actually easier and cheaper over the long term to actually just ingest it, put it in the library, and leave it there. Now, we are, as I said, tagging all of this. And I suspect once we stop doing the live record, I can go over our AI presentation if you really wanted to see it. If not, you can go to SMPTE and you can see it online as well. But we are using AI to do a lot of this. So.
But I'm still confused, and I'm
Oh, it's okay.
the pain, the heckler, pain in the ass in the back, but it's my job.
No, I thought that was my turn.
Yeah, sorry, I thought.
Are you with
further
WWE?
behind than you did all this time. But I'm just curious, do you see this enabling new business opportunities in the future, or is this just replicating product that you already make with local storage? You know,
This is twofold. We see it as a cost savings immediately by
because you are doing this.
yes, we are currently doing this. We have been doing this since 2007. So we see this as a product to help us reduce our costs overall. We see it as a product to be able to get us to doing those types of business quicker and also adding new business. You'll notice there was a future format out there. We don't know when Dash will be ready, right? We don't know when this is going to happen or that's going to happen. But because the cloud products are constantly updating, by simply purchasing a licensing key, we could stream to another format. We could do something else. We could support 360. So yes, we see this as potential for new business, but right now we see it as a cost savings overall.
So, but you're still looking at bringing that content in to the cloud and then potentially, basically live streaming from that cloud platform.
That is correct. Yes, we will bring it in and live stream and archive. This will not affect things for NBC, et cetera. And we do also do long tail content, right? So we produced a show in 1968 Darlington, right? Particular racetrack for the non-NASCAR fans. We've ingested it all, and we wanted to go back and tell a story about what had happened, or the Atlanta 400 race that was down here back in the 80s or 90s. So yeah, we're constantly trying to continue to bring back and give our fans what they're asking for, which is older content and some interesting stuff out there. Yes, Dan?
So one thing, Brad, how many paid apps does NASCAR have out there where people actually have to pay to download the app and use?
NASCAR personally has one, as a company, yes.
How much of that content is offloaded to other people that have apps that use that content?
A couple of other ones, yeah. We work with our broadcast partners to deliver as well.
Stuff going out there, and what he's doing is, being able to take that feed, turn it into HLF, put it right on your phone, correct?
That's correct, yeah. We're taking this and delivering it HLS, and for example, NBC, one of our broadcast partners, if they need to be encoding this a second time, we could just give them the Akamai entry point or whoever the CDN is, and we're good to go. So now we're reducing their costs overall. Yes?
In sports, at times, there's the desire to be able to have 4K. The football game where they want 4K because maybe what happened was not where the cameraman was really pointed. They may use a porthole. Have you looked at doing that? Have you looked at what the future will happen if you say, I'm going to go 4K, what happens to my bandwidth and everything else?
Yeah, so we have looked at that. We don't suspect we're making a 4K decision outside of ENG footage in the next year or so. We believe there's a current battle of the HDR solutions and 1080p and 4K, and we've bled enough on the front lines that we might just wait this one out for another year or so and figure it out.
Well, I was just thinking about the production advantage of being able to say, oops, something happened off in the bottom left corner, I can get it at full resolution.
Are you selling 4K cameras?
I'm talking.
Do you have any 4K trucks?
4K's old.
No.
We're now 8K.
Yeah. Oh wow, NHK over here. Well, we don't support 4K outside of the ENG environment. We work with third parties, so NEP and Game Creek, etc., and they supply the trucks should we need them. Right now, we don't see a distribution model for that today. It's not saying that we won't get a phone call and we won't go that direction, but no, we do not support 4K trucks. Yes, sir.
I saw ML and machine learning on your slide. How are you using it today, and then what is your roadmap as AI and machine learning gets more robust around your video metadata?
I'm very happy you asked. Machine learning. So Again, about 18 months ago, we said, is there any way we can, now we're injecting all this stuff into the cloud, right? Can we do something special with it? And we started looking at machine learning. In our particular case, we looked at Keras, we looked at TensorFlow, we looked at SSD, single shot detectors, we looked at all sorts of things out there. We came up with TensorFlow as our solution. We are open architecture, and we are looking at how we can take this and build our own models. The number one expert in NASCAR is NASCAR. We know our drivers, we have all the footage, and we can actually generate our own models. How many people know what models are out there? Wow. Who is the number 43 driver? Okay, we'll work on this one. A little more crowd engagement. So talk about AI models. How does something know who I am, right? I know Bob over here. I recognize him. I've met him once or twice, but in that small amount of time, I was able to figure out who he is. In fact, I'm actually able to figure out each one of you and hopefully remember who you are. I see some friends I haven't seen in years back there because my brain's memorized that. The human eye contains, the visual cortex contains about 125 million neurons. The brain contains about 1 billion. And that's what allows us to do facial detection and other things, right? So I recognize 2 eyes, a mouth, and a nose, and I've seen that long enough, I'm able to say, that makes sense, that's Bob. Well, if I get pictures of Bob from all the different angles, I can train a computer. That's simply what machine learning is. Very simple concept. And by blending those all together, I create a model, right? So now I could say, oh, you want to know what a Bob looks like? There's the Bob model, right? I could add other things into it. I could put a NASCAR car number in there, the 43. And it doesn't matter which direction, right? If Bob turns a little left or a little to the right, I should know what Bob looks like. Make sense? All nodding, we got this one. Okay, so what are we doing with that? Well, right now, if you're trying to think about it, not every kid out there who comes in their first job at NASCAR and they say, I want to log video. But they don't know who Richard Petty is. People out here didn't know who he was. So now I got to teach that person what Richard Petty looks like. And in fact, I have to teach them what every driver looks like since 1947. What about a driver who wasn't super famous that had one great race? Got to teach them what that looks like. Got to teach them about the car models. Got to teach all these different things. Well, that's expensive and it takes a lot of time. What if we did a first pass analysis on that and said, here's all the Richard Pettys, here's all the Jimmy Johnsons, right? Here's all the AJ Allmendingers, pick out who you want, right? And we've now identified them. Now, there are some flaws with this, and we can go over this at a later point in time. But the point is that we generate these models, and then we say, take all that video that's coming out of the robot into the cloud and analyze it based on what we know the 43 car to look like. And now we can say, it showed up on this frame, it showed up on that frame. That is our entire model structure right there. We've got sponsor logos, drivers, and personalities, if you will. So it's about 120 different people. And we're currently building this out right now. We have demonstrated this to work very successfully in a live model with a half-second delay. So if you're thinking about that, we can live detect something, and this is some amateurs, such as myself, and we're not experts in AI. We can now take a half-second delayed feed and add another half-second to it. Within a second, we can identify all the cars and all the things that are occurring within that scene. And you can do this too. There's a SMPTE presentation on this if you'd like to go download it, or it's on YouTube perhaps. You can see sort of our model and how we built it, and I suspect over the coming months we will give these out and maybe you can try it yourselves. It's pretty interesting technology. And because it's open source, we're not held to one cloud provider. In fact, you could run TensorFlow on a Raspberry Pi, small computer. You could run it in Azure or IBM or Google. In fact, Google actually invented it. It's called Brain, I believe. Anyway, does that answer your question?
Yeah, and to piggyback on that, are you using any open AI frameworks? And obviously, it sounds like you're using computer vision and all that. And are you going to basically continue to teach this and build the model over time so it's really relevant and smart?
Yes, that's correct. We are using TensorFlow. So it is a convolutional neural network, the closest thing that acts like a human brain, as simple as that or complex as it may be. And so what we do is we supply it with images, with 500 to 1,000 images on a pre-trained model. We're able to pick out human faces with great accuracy to the tune of like 96, 97%. There are some flaws with that, right? If a driver puts a helmet on, we lose the driver. If we were to analyze the helmet and the helmet was taken off, we would lose the driver because it was looking at a helmet. So we run into some flaws, but we think that overall in this process that we can gain more metadata using these open architectures such as TensorFlow. You can use, again, Keras, you can use anything out there, many tools out there. And we can enable our loggers to be more efficient. And that's our overall goal. And that was stemming from cloud contribution.
So that can be used really in marketing too, say how many cars are running an STP logo or whatever?
I will show you that probably in December. Yes, we look at sponsor logos and things like that. Now, keep in mind, these are all things that we're demonstrating and we've proven to be very successful, but we want to make sure that our models are really good on the first pass before we start loading content into the petabytes. So I am super excited to tell you more about this, and hopefully I will be able to legally in a couple of weeks. All right, thank you.